Hi, Assalamualaikum. Today we are going to continue from the polar curve part 1, and now it is part 2, where we're going to look now at the tangents to the polar curves. So now we have x is equal to r cos theta. When we differentiate this, we have to use the product rule. So we will have dx over d theta cos theta dr over d theta minus r sin theta. So we have to use u v prime plus vu prime, in which we will assume that u is equal to r and v is equal to cos theta in this case. So we differentiate this, you get u prime equal to dr over d theta with respect to theta, right? So v prime will be negative sine theta. So we substitute inside this formula, so we have this. Alright, now for the y equal to r sine theta, again we use the product rule. So we will have dy over d theta, which is given by this formula. So when we want to find dy over dx, we have to use dy over d theta divided by dx over d theta. So we already have dy over d theta here, and we also have dx over d theta. So substituting this into this formula, we will have this formula. Alright, so this is the formula for dy over dx, which is given by sine theta dr over d theta plus r cos theta divided by cos theta dr over d theta minus r sine theta. For the horizontal tangent, we will consider the part where dy over d theta, which is equal to 0, meaning to say that this part will be equal to 0. But for the vertical tangent, so we will use this denominator will be equal to 0. Right, now let's look at this example. Find the slope of the tangent line to the curve, to the polar curve, are equal to 2 sine theta at this point. Right, so what we have to do first is to find dy over dx. But to find dy over dx when given r equal to 2 sine theta, therefore we have to find the differentiation of r with respect to theta. So we have dr over d theta, which is given by 2 cos theta. Now we want to substitute inside this formula. So this is the formula where we are going to substitute the value of dr over d theta and also the value for r here. So this is the value for r and this is dr over d theta. We substitute inside this formula, we have this one. Simplifying this, we will have 4 sine theta cos theta divided by 2 cos squared theta minus 2 sine squared theta. But recall the trigonometric identity. We have that if we have 2 sine theta cos theta, then it will be equal to sine 2 theta. And if it is cos squared theta minus sine squared theta, therefore it is actually cos 2 theta. Therefore we simplify this, we'll have this cancelling 2 together with 2, therefore sine 2 theta divided by cos 2 theta will have tangent 2 theta. Alright, so this is dy over dx at any points, but now we want to specify at points theta equal to pi over 6. So now, meaning to say that we want to find dy over dx at this point. So we will have to substitute the value of theta with pi over 6. Therefore, we will have tangent 2 of pi divided by 6. Therefore, we'll have tangent pi over 3. Recall the triangle that I've taught before. So this is what we get for tangent of pi over 3 is actually root 3. Alright, so this is the answer. Root 3 is the answer, which is the slope of the tangent to the polar curve at this point. Now, let's look at example 10 here. We have to find the points on the curve r equal to 1 minus sine theta where the tangent line is horizontal or vertical. Meaning to say that we have to do one by one. Where the tangent is horizontal and the part for the the tangent is vertical. So let's do one by one. To do that, we have to firstly what we call differentiate r. So we have dr over d theta, which is given by negative cos theta. So firstly we focus on the horizontal tangent. For the horizontal tangent, we must use this rule where dy over d theta, which is equal to 0. So now because we have dy over d theta, so to find dy over d theta, so we know that from the formula. Alright, how do I get this? Because we have y equal to r sine theta. Therefore, differentiating y dy over d theta using the product rule, we have this formula. Alright, So we already have r and we already have dr over d theta. So we want to substitute this function here. All right. So we substitute it with these two functions. So we simplifying it. So we get cos theta minus 2 sine theta cos theta. So you still have to simplify this. So we factorize the cos theta here. Right. So we have cos theta 1 minus 2 sine theta. So now we want to solve for the part where dy over dx, which is dy over d theta, which is equal to 0, meaning to say that we want to equate this equal to 0. So we have that dy over d theta, which is equal to 0. So we want to solve these trigonometric equations actually. So solving this, we'll have this part which is equal to 0 and this part which is equal to 0. So we have cos theta equal to 0 and another one 1 minus 2 sine theta which is equal to 0 can be simplified as sine theta which is given by half. So we want to find the points where theta which is for points theta where the cos theta is equal to 0. So using the graph for cos, all right, if you recall the graph for cos is something like this where it is 0, so at this point and also at this point. So we have theta which is given by pi over 2 and 3 pi over 2. For sine theta which is half, you have to find the basic angle. You can use your calculator. So in this case you get 30 degrees, so 30 degrees is actually pi over 6. So you know that for the when you have 30 degrees, all right, so this is for the first quadrant, but for the second quadrant also we have 30 degrees here. Why? Because we have ASTC, acoustic. Solving this 30, all right, this angle and also this angle actually. So pi over 6 and also 5 pi over 6. We have these two angles. All right, settle for this part. But bear in mind that we are not done yet because there's something else here after this. All right, afterwards I'll show you. Now we go to horizontal tangent. When will we have the horizontal tangent? When dx over d theta which is equal to 0. So we want to find dx over d theta. So we have to use the product rule because we have x equal to r cos theta. Therefore the x over d theta we can find this using what do we call product rule. So we have this. So now we substitute dr and d theta, dr over d theta and also r. So we substitute with these two. So we will have this one, right? So simplifying this, we'll get sine squared theta minus cos squared theta minus sine theta. So we have to simplify again by substituting the identity for cos squared theta. So we have this. Right, note that this is like quadratic equation, so we know that when we equate it to equal to 0, we can solve it. So dx over d theta, which is given by this, is equal to 0. So we equate in equal to 0. All right. So to solve this, we have to factorize this quadratic equation of the trigonometric equation. So we have sine theta minus 1 times 2 sine theta plus 1, which is equal to 0. So only then we can say that this one equal to 0 and this part equal to 0. Or right, so we have sine theta minus 1 equal to 0 or 2 sine theta plus 1 equal to 0. We have to simplify this. We have sine theta which is equal to 1 and another one sine theta which is equal to negative half. So we have to find the value theta now. So theta for the first part which is 1, when is theta which is equal to 1? So it is something like this. So when this part is pi over 2, and another part where theta which is equal to 7 pi over 6 and 11 pi over 6. How do I get this? All right, so firstly you find the basic angle. You know how to find the basic angle. You just find sine inverse of half without the negative sign. You put in your calculator, you get 30 degrees. So plotting your 30 degrees, all right, so ASTC. But now it is negative. Because it is negative, so for the sign which is negative, which is in the third and fourth quadrant, so it is actually here. So this is 30 degrees, so this is 30 degrees. How do you find the angle from this to this and also the one from this to that? So this is the angle, all right? So you have to find this angle. But please note that from the horizontal and vertical tangents, which point do they have the same in common? All right, so actually we have theta which is pi over 2. So you have to decide whether pi over 2, at this point the tangent is actually horizontal or vertical. To do this, you have to do extra works here. All right, So firstly, we have from the previous slide that dy over d theta and dx over d theta given by this function. So we can find dy over dx. Why? Because we have the formula for dy over dx, which is given by dy over d theta divided by dx over d theta. So this is dy over d theta, and this one is dx over d theta. So now we have to find the limit, because we want to determine at the point theta which is equal to pi over 2. Therefore, we should find the limit, all right, from left and also from right of theta over 2. So we have to find, all right, let's say we start with finding the limit of dy over dx for theta which is approaching pi over 2 from right. Therefore, we find the limit of this function actually, all right. But to find the limit, we know that the properties of the limit, we can find the limit of this, we can find the limit of this, all right, the limit of two functions being multiplied, and then we can separate them together, all right. All right, like for example this one, all right, I find the limit for this part, multiply with the limit for this part. This is what I do here. So we substitute the value of theta which is equal pi over 2, right, for this part only, all right, because we can only find theta the values for theta equal to pi over 2 for these functions only, all right. For this one, hold on, right, hold on, let me tell you what need to do. Right, so we will have this, all right. So this one we don't do anything yet, but this one we substitute with theta which is equal to pi over 2, so we have this one. Right, so simplifying this, all right, we'll get 1 minus 2 which is negative 1 over 3. Right, so we will have negative 1 over 3 limit of this one. All right, now we want to use some other knowledge for this calculus, right? So we can actually find, because if you substitute with pi over 2, we will have I think 0 over 0 case, all right. This is 0 over 0 case. So what do we need to do? We can use the L'Hopital's rule. Remember L'Hopital's rule. How to do this using the L'Hopital's rule? You can differentiate the numerator and also denominator. So when differentiating cos theta, you get negative sine theta. Differentiating sine theta minus 1, you get cos theta. Therefore, we will have this one, right? Differentiating cos theta, negative sine theta, and differentiating the denominator, we get cos theta. And then I want to take out that negative, so I can bring that negative out because it's just a constant there. So that one is negative 1, so negative multiplied by negative here, so we'll get positive 1 over 3. Now please take note that limit of theta approaching pi over 2 from right of this sine theta over cos theta, we can simplify sine theta over cos theta as tangent theta. So we have this one. So recall the graph for tangent theta, all right. How do I get this negative? All right, so this is the graph for tangent theta. We want to go to this graph, all right, tangent theta as theta approaching pi over 2 from right. So this is the pi over 2 approaching pi over 2 from right is this way, so it's actually going right negative infinity. So the graph is going negative infinity. That's why I have negative infinity there. Next, we have to find the limit of this dy over dx as theta approaching pi over 2 from left. So we have this function, so we want to find it from left, so we can actually use here, right? So this is actually equal to 1 over 3 limits of theta as approaching pi over 2 from left of tangent theta. So now look at your graph of tangent. You are approaching the pi over 2 from left, so this is from left of pi over 2. So you look at this graph, it's actually going upwards there, so it's actually positive infinity. So this is what you have. So we note that limit for pi over 2 approaching from right is negative infinity, and limit of dy over dx as theta approaching pi over 2 is negative infinity. And from left is positive infinity. So this shows that at this point pi over 2, it is a vertical tangent, not the horizontal tangent. All right, so go back to your slide, all right, just now. So because it says that it is vertical, not horizontal, so this one is vertical, not horizontal, so we can cancel this part, right? So we cancel that, right? So meaning to say that for horizontal tangent, we consider only this one, this one, and this one. If the question asks you to find the points, therefore you have to find the coordinates. How to find the coordinates? Because this is just the theta, you just substitute the value of theta, which is like, for example, 3 pi over 2. So you substitute inside r. So what values of r you get? So you get the, all right, so 3 pi over 2. I don't show fully here, all right. So like, for example, all right, sine of 3 pi over 2, sine of 3 pi over 2, you get -1. So -1 minus 1, sorry, 1 minus -1, you get 2. So 2, all right, 2 3 pi over 2. You should do the same thing for this, all right, for this pi over 6 and also 5 pi over 6. All right, find the values of r here. All right, so that's the points where we have the horizontal tangent, but for the vertical tangents you have to, all right, find the theta. All right, this theta, with you substitute inside r here, and then you get the points in polar coordinates. All right, that's it. Let's go to example 11 here. We have to find the points on the curve r equal to 1 plus cos theta, where the tangent line is horizontal or vertical. So again, we'll just need to do the same thing here. Firstly, we have to find the r over d theta, which is given by negative sine theta. Now, for the horizontal tangent, we must find dy over d theta, and then we equate it to 0. So dy over d theta, all right, given by this formula, we already have dr over d theta and also r here. So substitute dr and d theta over d theta and r here. So we have this substitution here. Now you just need to simplify this one. You get cos squared theta minus sin squared theta plus cos theta, and then you use all right, because we have cos theta there, then we want to remove this sin squared theta. So you substitute with 1 minus cos squared theta. Therefore we simplify this, we got 2 cos squared theta plus cos theta minus 1. Right, what's need to be done in the next step? We need to equate this equal to 0. So we will have this, all right, sorry, all right, if you want to, what do we call, factorize this also, okay, huh? All right, so you factorize this one and then you equate this equal to 0. Right, so this one you have this equal to 0, meaning to say that this is equal to 0 and this part is equal to 0. So you have these two equations. So you simplify this, you get cos theta equal to half, or cos theta equal to -half. So when is cos theta equal to half, all right, so you get theta, which is given by pi over 3 and 5 pi over 3. Another one for theta, which is cos theta equal to -1, where theta is equal to pi. All right, settle for this one. Now we are going to find the points where we have the vertical tangent. So for the vertical tangent, we have to find dx over d theta. So for dx over d theta, which is given by this formula, right, if you don't remember this, or just remember x is equal to r cos theta, therefore find dx over d theta using the product rule. All right, now you have this one, so you just need to substitute the function dr over d theta and also r. So you get this one. All right, simplifying this, you get negative sine theta minus 2 sine theta cos theta. Now we have this one, this one can be factorized as this. All right, now we want to let this equal to 0 because we want to equate this equal to 0. So now we have this one equal to 0. You can directly cancel that negative in front here because it is already equal to 0. So we have sine theta, which is equal to 0. All right, and another one, this one. All right, this one equal to 0 and also this one equal to 0. So 1 plus 2 cos theta, which is equal to 0, which can be simplified as cos theta, which is given by -half. Now we want to find the points for theta when sine theta, which is equal to 0, and also cos theta when it is equal to -half. So sine theta, which is equal to 0, so theta we got 0, pi, and 2 pi. How do I get that? All right, so this is it, 0, pi, and 2 pi. But for the cos theta, which is equal to -half, so how do I get that points? So actually you have to use your calculator. All right, so you find the basic angle. How to find the basic angle? I repeat, you just need to find cos inverse of half without negative. Right, inside your calculator, so you get actually 60 degrees. So using your ASTC, akustesi ini. All right, this is akustesi. All right, so when is cos negative? Cos when is actually here. All right, so now this is 60 degrees and this is 60 degrees. So the angle is from this to this and this one. All right, right. So you can get 2 pi over 3 and 4 pi over 3. All right, so that's the theta. But for the, what do we call, for these both points, for these horizontal and vertical tangents, which theta have the same value? So in this case we get theta is equal to pi, and also this one equal to pi. So we have to determine at theta equal to pi whether it is actually horizontal or vertical. So we have to find the limit again. So to find the limit, we have to find the limit of dy over dx. So to find the dy over dx, we already have dy over d theta and dx over d theta. Substituting inside the formula for dy over dx, which is given by dy over d theta divided by dx over d theta. Therefore this is dy over d theta over here, and this one is dx over d theta. We put it here. Right, don't forget that negative sign, right? Now we want to find the limit as theta, all right, approaching pi. Remember why? Because at theta equal to pi, we have it in horizontal or vertical. All right, we have to determine, so we have to do this. So find the limit as theta approaching pi for dy over dx. So as theta approaching pi for dy over dx, we will have this one. All right, how do I do this? All right, I find the limit of this, all right, and also this one. We can divide into two functions here. All right, so we can substitute the value of theta, which is equal to pi, for this part, but not for this part, because we will have the 0 over 0 case. All right, so right now we substitute, right, so with pi here, so we will have this. But this one, how do I get this? Using L'Hopital's rule. L'Hopital's rule, right? We differentiate the numerator and we differentiate the denominator separately. So we'll have this one. So simplifying this, we can cancel this negative here. So you simplify this, you get 3, right? Limit as theta approaching pi of tangent theta. Tangent theta, all right, so recall the graph for tangent theta. This is the graph for tangent theta as theta approaching pi. So as theta approaching pi, from left or from right, it goes to 0. That's why I don't write limit from left or limit from right. So if you want to show that, it's okay, right? But still you get 0 here, because this part will become 0. So we have 3 multiplied by 0, you get 0. Since limits of dy over dx as theta approaching pi is equal to 0, therefore at theta equal to pi, it's actually a horizontal tangent, not the vertical tangent. Alright, so you go to this, it's actually a horizontal tangent but not the vertical tangent. Alright, so we don't have it there. Alright, so for these questions, when theta equal, where are the theta when we have the horizontal tangent? At this point, right, at this point and this point. But right, for the vertical tangent, the theta will be 0, 2 pi, this one and this one. All right, that's it. Right, now let's look at the definition for the arc length of the polar curve. For the curve with the polar equation r equal to f theta, where theta is between a and b, its length is actually given by this formula. Alright, so we just need to use the formula. Let's look at this example. Find the length of the curve r equal to 2 sine theta, where theta is between 0 and 2 pi. So what we need to do is to find the differentiation of r with respect to theta. So we have dr over d theta, which is given by 2 cos theta. Now we want to use this formula. You just need to substitute the function r and also dr over d theta here. So we have this this equation, right? So you're expanding that square here, so we have 4 sine square theta plus cos square theta. I factorize 4 then. So using the identity, this part will become 1. Sine square theta plus cos square theta will equal to 1. So this one will become root 4. Root 4 is actually 2. So we have integration from 0 to 2 pi of 2 d theta. So to integrate this, we'll get 2 theta. So we have to substitute from 0 to 2 pi. So substitute theta with 2 pi minus 0. So we'll have 4 pi is the answer. So the length of this curve, alright, as can be seen here, so it's actually 4 pi. Okay, that's it. Now, last one. We have to find the intersection point between these two curves. So what do we need to do? Because it intersects, so we have these two curves, so it intersects. So you equate this with this one. So you have this one, 5 sine theta equal to 2 plus sine theta. Simplifying this, you bring this sine theta to the left side, so we have negative, right? So we simplify, we get 4 sine theta which is equal to 2, then sine theta which is equal to half. When it's sine theta which is equal to half, using your basic angle, you get theta is actually equal to 30. Alright, so this is ASTC, acousticity, right? So this is 30 when it's sine positive, so this one 30. So the angle is from this to this, another one is from that to that, right? So we will have theta which is equal to pi over 6 and also 5 pi over 6. That's it. Thank you for watching.